In 2015, when NASA's New Horizons spacecraft flew past Pluto and sent back its first close-up images, scientists around the world were stunned. What those images revealed was a Pluto entirely different from what we had imagined. On its surface, icy volcanoes erupt, where frozen lava bursts upward and solidifies almost instantly in the frigid atmosphere. Smooth plains of nitrogen ice stretch across the landscape, remarkably free of impact craters. This suggests that Pluto is still geologically active, possibly holding signs of hidden, primitive life. Could it be that beneath its frozen shell lies a subsurface ocean? One of Pluto's most intriguing regions is Sputnik Planitia, a vast, heart-shaped plain made primarily of frozen nitrogen and methane. In this strange terrain, the movement of materials appears to mimic convection in Earth's mantle, hinting at a mysterious internal heat source we have yet to fully understand, though it resides on the distant edge of the solar system. Pluto maintains a thin atmosphere made mostly of nitrogen, and yet it experiences climate shifts on a timescale of centuries, sometimes producing thin clouds and hazes. Could Pluto have undergone climate cycles of its own, much like Earth, but written in an entirely alien rhythm? All of this makes Pluto a world of contradictions, remote yet dynamic, frozen yet possibly alive, a strange, beautiful mystery still waiting to be explored. Pluto was once hailed as the 9th planet of the solar system, ever since its discovery in 1930 by astronomer Clyde Tombaugh. But in 2006, a seismic shift occurred. The International Astronomical Union introduced a new definition of the word planet, requiring any celestial object to meet 3 criteria. It must orbit the Sun, it must have enough mass for its gravity to form it into a sphere, and it must have cleared its orbital path of other debris. Pluto met the first 2 conditions, but failed the third. It shares its orbital space with countless other objects in the Kuiper Belt. And so, Pluto was officially downgraded to a dwarf planet. The decision ignited immediate controversy. Many scientists, including members of NASA and even the New Horizons mission team, challenged the new classification. They argued that Pluto is more than just a small body. It has an atmosphere, it has towering mountain ranges, it shows evidence of geological activity, and it may even harbor a subsurface ocean beneath its icy shell. The mystery was fueled by the technological limitations of the time. Images of Pluto, even from the Hubble Space Telescope, were no more than faint, blurry specks. As strange as it sounds, this made sense. Pluto is so small and so far away that its angular diameter in the sky is extremely tiny. Smaller than that of distant galaxies millions of light years away, which appear clearer simply because they cover a larger visual angle. That very blurriness added to Pluto's mystique. A planet once celebrated, then cast out, yet never forgotten. A world that continues to defy our understanding of the cosmos. And perhaps, deep down, we wonder, did we underestimate a world we've never truly seen? But the question of Pluto's status as a planet is just the beginning. What came next, towering ice mountains, youthful nitrogen plains, and hints of a hidden ocean, may very well force us to rewrite the definition of planet itself. On January 19, 2006, while debate still raged over Pluto's planetary status, NASA launched New Horizons, a spacecraft on one of the most ambitious journeys humankind had ever attempted, which a voyage of over 3 billion miles through the solar system to reach a frozen world no spacecraft had ever touched. Then, in July 2015, after 9 years drifting through the vastness of space, the first images began streaming back. They shattered everything we thought we knew. Pluto wasn't a barren, lifeless rock. It was dynamic, mysterious, unlike anything we had seen before. Front and center was Sputnik Planitia, a massive heart-shaped plain stretching hundreds of kilometers, blanketed in smooth nitrogen ice. Shockingly, this region had no impact craters, an unmistakable sign of a geologically young surface, perhaps only tens of millions of years old. A world once thought to be a frozen fossil of the solar system. It posed a daunting question. Why is Pluto still geologically active? The closer we looked, the more astonishing it became. Sputnik Planitia is etched with massive polygonal patterns, reminiscent of dried, cracked mud. But these are not cracks. They are the fingerprints of convecting nitrogen ice, hinting at a hidden energy source deep within Pluto's interior. Along the plain's edges rise towering mountain ranges, some soaring 3 to 4 kilometers high. But these mountains aren't made of rock, they're made of water ice, which in Pluto's minus 380 Fahrenheit temperatures is as hard as granite. Their existence points to a violent past, perhaps uplift, cryotectonic collisions, or the contraction of a freezing crust. And then came the most extraordinary discovery of all, cryovolcanoes. Two massive structures, Reitmans and Picardmans, stood out with their conical shapes and deep central pits. These are not lava-spewing volcanoes. Instead, they may have once erupted water, ammonia and methane freezing in mid-burst. This isn't science fiction, this is real. Proof of a cold planet with the potential to harbor life beneath its icy shell. Another breathtaking feature, Tartarus dorsa, a series of jagged ridges that twist like the scales of a serpent. These formations may be the result of a rare phenomenon known as penitentes, where sunlight sublimates ice into towering spikes. On Earth, these are only seen at high altitudes. In space, never, until now. And on the opposite hemisphere, a massive dark stretch emerges, Cthulhu Macula. This ancient scar, nearly 3 kilometers long, is shrouded in deep red hues and pocked with some of Pluto's oldest craters. Scientists believe its color comes from tholins, complex organic compounds formed by solar radiation interacting with methane in Pluto's atmosphere. These molecules are tied to prebiotic chemistry, the potential raw ingredients of life. New Horizons didn't just return data, it rewrote the story. Pluto is not a dwarf planet relegated to obscurity. It is a living world shaped by mysterious internal forces, sculpted by icy mountains and volcanoes, and veiled in organic compounds that echo the beginnings of life. This wasn't just a discovery. It was a revelation. In the cold and distant reaches of our solar system, the smallest, most overlooked places can hold the greatest secrets. Pluto reminds us that the definition of a planet and even life itself is far from settled, and the universe is still full of wonder. What happens above Pluto's surface is even stranger than what lies below. This frozen world hosts an atmosphere so thin, yet so unexpectedly complex, it continues to astonish scientists. New Horizons confirm that Pluto's atmosphere is primarily composed of nitrogen, just like Earth's, but it also contains traces of methane and carbon dioxide. Despite a pressure hundreds of thousands of times lower than Earth's, it's still dense enough to form hazy layers that stretch hundreds of kilometers above the surface. One of the most astonishing discoveries was the presence of atmospheric haze. Not a single layer, but 20 distinct layers captured in breathtaking backlit images taken as the sun shone from behind Pluto. These delicate stacked veils drift through Pluto's cold twilight sky, bending and refracting sunlight into mesmerizing halos, like a frozen sunrise at the edge of the solar system. This atmosphere is not stable. It lives and breathes with Pluto's long orbital cycle. As the planet approaches the Sun in its eccentric orbit, frozen nitrogen and methane on the surface begin to sublimate, forming a thin envelope of gas. But when Pluto retreats to the distant reaches of its orbit, that same atmosphere condenses, slowly falling back to the ground as frost, an ebb and flow that unfolds over centuries. Yet, even at that incredible distance, where the sun is just a bright star among others, light still plays its part. Against all odds, it's enough to illuminate Pluto's surface in detail. Thanks to the scattering of light by haze particles and the efficient reflection from Pluto's unique terrain. But perhaps the most intriguing question is what this atmosphere might mean for the potential for life. Methane, when bombarded by cosmic radiation, can transform into tholins, complex organic molecules long suspected to be the building blocks of amino acids. As these particles settle onto Pluto's surface, they may deliver a type of prebiotic chemistry, opening the door to a powerful speculation. Could the seeds of life exist even in the most remote corners of the cosmos? Pluto's atmosphere forces us to rethink what makes a world alive. It doesn't need to be thick like Earth. It doesn't require raging winds or torrential rain. It simply needs to exist, to shift with the seasons, to shimmer in the light, and to whisper secrets of something deeper. Because part of Pluto's atmosphere may not be born only of sunlight, but of something stirring far beneath the ice. A resonance, a signal, the possibility that beneath the frozen nitrogen crust lies a hidden ocean, one that has quietly endured, holding within it the ancient echo of life never before seen. As Pluto's thin, elusive atmosphere was confirmed to wax, wane, and even expand with the seasons, a natural question followed. What kind of energy could possibly sustain such activity on a world teetering at the frozen edge of the solar system? The answer, scientists believe, may lie beneath Pluto's icy crust, stretching dozens of kilometers deep, where bold new models are converging on a radical hypothesis. Pluto might harbor a subsurface ocean that remains in a liquid state even today. The first clues come not from what's seen, but from what's missing. If a primordial ocean had once existed and later froze solid, the surface ice above it would contract, leaving behind global-scale fractures. But curiously, large regions like Sputnik Planitia show no such signs. Instead, they appear supported from below, hinting at a layer of soft ice, or perhaps even liquid water beneath. Strengthening this theory is Pluto's internal energy source. Though small, Pluto contains radioactive isotopes such as uranium-238 and thorium-232. These continue to decay over time, releasing a steady flow of heat within its rocky core. Insulated beneath thick layers of nitrogen and water ice, this heat could be enough to preserve liquid water, especially if mixed with natural antifreeze agents like ammonia. Beyond geological hints, gravity itself tells a compelling story. Sputnik Planitia, a vast low-lying basin, sits unusually close to the point on Pluto's surface directly opposite its largest moon, Charon. This odd alignment breaks the rules of mass balance. Unless, beneath that basin, lies a dense subsurface ocean. Over millions of years, the gravitational pull of such a hidden mass could have dragged Sputnik Planitia into its current position. It's indirect but powerful evidence drawn from dynamical modeling and orbital mechanics. And with the idea of liquid water comes the age-old question of life. Even in Pluto's sealed, sunless, high-pressure environment, if basic organic compounds are present, and fueled by the slow burn of radioactive decay, conditions could exist for a primitive chemical-biological ecosystem. The scenario mirrors those proposed for subsurface oceans on Europa or Enceladus. No spacecraft has yet drilled through Pluto's ice. But every simulation, every radar map, every gravitational anomaly, together they point to one realistic possibility: that Pluto may still cradle an ancient underground sea. A place without light, without wind, without sound, possibly harboring the oldest chemical reactions in the solar system's history. And if that is true, then this distant world may be silently nurturing a story of life no one has ever known. If Pluto's hidden ocean is the silent keeper of secrets buried deep within, then its moons are the visible clues, the celestial whispers, that Pluto is not just a planet, but a fully realized system, intricate, dynamic, and far from fully understood. At the heart of this system lies Charon, a moon so massive, nearly half the diameter of Pluto, that it challenges conventional definitions. In fact, the gravitational center between Pluto and Charon doesn't lie inside Pluto itself, but in open space between them. Making this pair the only known binary dwarf planet system in our solar system. Charon is tidally locked with Pluto, not just showing the same face to its host like Earth's moon, but in return, Pluto also shows the same face to Charon. This rare gravitational harmony creates a cosmic dance, frozen in space, two celestial bodies eternally facing one another in perfect stillness. Amid the cold, but it's Charon's surface that truly intrigues scientists. Images from New Horizons revealed a network of massive fractures, some stretching hundreds of kilometers deep. Straight scars slicing across its surface. These features hint at a geologic upheaval, and many scientists believe they may be remnants of an ancient subsurface ocean inside Charon. That froze and expanded, cracking the outer crust apart. Even stranger is a dark red stain near Charon's North Pole, with no internal source. Researchers believe this mysterious cap is made of tholins. Tholins, complex organic compounds formed when methane molecules escaping Pluto's thin atmosphere, drift to Charon, and are transformed by radiation. Incredibly, even Pluto's faint atmosphere appears to have chemically marked its moon. a microscopic but meaningful form of interplanetary interaction. Farther out, 4 tiny moons, Nix, Hydra, Kerberos, and Styx, each only a few dozen kilometers wide, defy expectations. Despite their irregular shapes, they orbit in nearly perfect circles on the same plane, an unusual trait for such small bodies in the chaotic Kuiper belt. What's more, they are not tidally locked. Instead, they tumble unpredictably, spinning erratically with no fixed rhythm, and extremely rare behavior in our solar system. And yet, their orbits remain stable over billions of years. Why? Together. Charon and its companions aren't just satellites orbiting a distant dwarf planet. They are physical evidence that Pluto is a gravitational world with dynamic interactions, tectonic history, and evolutionary complexity on par with any full-fledged planet. Once dismissed as peripheral, Pluto now reminds us that even the smallest worlds can harbor mysterious moon systems, places where oceans may have once flowed. Collisions reshaped history, and silent stories still remain, waiting to be uncovered. According to NASA's projections, the spacecraft's primary power source, its radioisotope thermoelectric generator, should function reliably until at least 2030. That means we still have at least 5 more years to search for distant objects. Explore unnamed celestial bodies and delve deeper into the Kuiper belt. A region we've only just begun to scratch the surface of. Right now, the New Horizons team at the Johns Hopkins Applied Physics Laboratory is actively searching for a new flyby target. Using the most powerful telescopes on Earth to identify a candidate that is both close enough and compelling enough to pursue. Meanwhile, terabytes of data from Pluto and Arrokoth are still being processed line by line. Because of the immense distance and the sluggish pace of deep space transmission. In other words, even now, years after its primary mission ended in 2015. Pluto continues to reveal new secrets. Beyond scouting physical targets, New Horizons has taken on a second life as an interplanetary laboratory. Equipped with instruments that measure energetic particles, cosmic dust, plasma, and radiation. It's delivering unprecedented data about the environment of deep space, a place largely untouched by the solar wind, and free from the interference of large planetary bodies. This information is helping space physicists refine their models of the solar system's outer boundary. Particularly the heliosphere, the magnetic bubble that shields us from galactic radiation. Such insights not only enhance our understanding of the interstellar medium, but are also shaping the design of future missions. Missions that may one day carry humans beyond Pluto's orbit. Pluto, supposedly demissed and demoted, is gradually becoming a critical research outpost, a convergence point of frozen geology, dynamic atmosphere, possible hidden oceans, and a bizarre moon system. And New Horizons, once just a one-time flyby probe, is now a mobile laboratory. Carrying instruments that serve multiple disciplines: astronomy, plasma physics, cosmic chemistry, and planetary geology. We still don't know if Pluto truly hides an ocean beneath its crust, or whether its tiny moons once collided and reassembled. But one thing is certain: Pluto has not finished telling its story. And as long as New Horizons continues to transmit, every kilobyte of data it sends back has the potential to reshape our understanding of the solar system's frontier, where what seems like an ending may in fact be the beginning of a brand new question. As New Horizons continues to transmit its final streams of data from the distant edge of our solar system, we're left to confront a simple yet often controversial truth. Pluto never needed to be a planet to matter. In a solar system where most of our energy, attention, and definitions revolve around the giant planets, Pluto stands apart in orbit, in structure, and in scientific status. But it is precisely by standing apart that Pluto has managed to preserve what the larger worlds have long since lost, a near pristine state. Geological traits unlike any other celestial body, and a satellite system that defies the expectations of classical dynamics. On Pluto, we found towering ice mountains rivaling the Rockies, nitrogen plains that flow like the crust of a living world, cryovolcanoes that erupt frozen slurries, and a delicate atmosphere that shifts with the seasons. We've seen unfractured regions hinting at a stable subsurface ocean, and a moon so large and close that it forms a fully locked binary system. We've witnessed tiny moons in chaotic, unpredictable orbits that still somehow remain stable. Challenging the very foundations of orbital mechanics. And we've gone even farther too at Arcava to confirm that even the smallest, most distant objects can hold the missing keys to how planets come into being. All of this time what was once dismissed as a dwarf planet, a frozen remnant deemed dynamically irrelevant. And unceremoniously stripped of its planetary status for not clearing its orbit. But when we finally got close, Pluto revealed a level of complexity, structure, and activity that many full-fledged planets can't match. And at that point, the labels ceased to matter. Pluto became a symbol of what is overlooked and how those things, once explored, can raise bigger questions than any definition can contain. In science, value isn't determined by size or rank on a list. But by how much it forces us to rethink our view of the world. Pluto did that, and it still does. With every stream of data, every layer of atmosphere, every frozen scar upon its surface. That's why Pluto deserves our respect. Not because it's a planet, because it reminds us that the smallest worlds often hide the greatest mystery.